Hello everyone, welcome to Chemistry Shorts. Today let's discuss some of the numerical answer type questions that came for GATE 2021 for 2 marks. So the first question is the number of photons emitted per nanosecond by a deuterium lamp of 400 nanometer wavelength having a power of 1 microwatt is. So we know that the equation of energy E is equal to h nu, that can be written as hc by lambda. Now substituting the values of these 6.626 into 10 raised to minus 34 kilogram meter square second raised to minus 1 into 3 into 10 raised to 8 meter per second divided by 400 into 10 raised to minus 9 meter. On solving this, we'll get 0.0497 into 10 raised to minus 17 kilogram meter square second raised to minus 2, which is nothing but joules. Now they have given power 1 microwatt. So power P is equal to 1 microwatt. We know that 1 watt is equal to 1 joule per second. 1 watt is equivalent to 1 joule per second, right? So we can write power 1 microwatt is equal to 10 raised to minus 6 watt. That is equal to 10 raised to minus 6 joule per second. Now to find the number of photons, the power P divided by energy E, that will give the number of photons emitted. Now P by E is equal to 10 raised to minus 6 joule per second divided by 0.0497 into 10 raised to minus 17 joules. That will give 2012 into 10 raised to minus 9 second inverse. So since in the question they have asked for number of photons emitted per nanosecond, the number of photons emitted per nanosecond will be 2012 per nanosecond. Okay, so this will be the answer. Moving on to the next question. Given the initial weight of 1 milligram of radioactive cobalt, whose half-life is 5.27 years, the amount disintegrated in 1 year is dash mg. Now we know that for the half-life, the equation for half-life is T half is equal to 0.693 by lambda, where lambda is the TK constant. Now they have given T half is equal to 5.27 years. So lambda, on substituting the value of T half, we'll find lambda equal to 0.131. Now the equation that we have known for the radioactive decay is T is equal to 2.303 divided by lambda log A0 by AT, where A0 is the initial mass and AT is the final mass of the sample. Now they have asked for the case of T is equal to 1 year and A0 is given as 1 mg. Now substituting the value here, we can write log A0 by AT is equal to 1 into 0.131 by 2.303, which is equal to 0.057. Now the initial mass A0 is given to be 1 mg. So substituting the value of A0, log 1 by AT is equal to 0.057. Now 1 by AT will be antilog of 0.057, which is calculated to be 1.14. Now AT, that is the mass remaining after T time, that is 1 year, that is equal to 0.88. That is, the amount remained after 1 year is 0.88 mg. So we have to find the amount disintegrated in 1 year. So the amount disintegrated in 1 year will be the initial mass A0 minus the amount remained after 1 year, that is 0.88. 1 minus 0.88, that will be 0.12 mg. Moving on to the next question. The de Broglie wavelength of an argon atom whose mass is 40 AMU traveling at a speed of 250 meter per second is dash picometers. We know that the de Broglie wavelength is given by lambda is equal to h by mv. Now m is given to be 40 AMU. Let's convert AMU to kilogram, so that 1 AMU is equal to 1.66 into 10 raised to minus 27 kilogram. So 40 AMU is equal to 40 into 1.66 into 10 raised to minus 27 kilogram. Now substituting the values in this equation, we will get de Broglie wavelength lambda is equal to 6.626 into 10 raised to minus 34 kilogram meter square second raised to minus 1, which is nothing but h, divided by 40 into 1.66 into 10 raised to minus 27 kilogram into the velocity is given as 250 meter per second. So into 250 meter per second. So on solving this, we'll get lambda equal to 39.9 into 10 raised to minus 12 meter. And we know that 1 picometer equal to 10 raised to minus 12 meter. So that lambda equal to 39.9 picometers. So the next question, the molar absorption coefficient of a substance dissolved in cyclohexane is 1710 liter mole raised to minus 1 centimeter raised to minus 1 at 500 nanometer. The reduction in the intensity of light of the same wavelength that passes through a cell of 1 millimeter path length containing a 2 millimolar per liter solution is dash percentage. So we know that the equation of absorbance A is equal to log I0 by I, where I0 is the initial intensity and I is the final intensity. That is equal to epsilon Cl, where epsilon is the molar absorption coefficient, C is the concentration and L is the path length. So log I0 by I is equal to, on substituting the values of these given in the question, we'll get 1710 liter mole raised to minus 1 centimeter raised to minus 1 into 2 millimolar liter raised to minus 1 into the path length, that is 1 millimeter. So 1 millimeter. Now making all the units in same terms, like in same units we are converting all the units. So we'll get log I0 by I is equal to 1710 liter mole raised to minus 1 centimeter raised to minus 1 2 into 10 raised to minus 3 mole liter raised to minus 1 into 10 raised to minus 1 centimeter. On solving this, we'll get 0.3420. Now I0 by I will be equal to antilog of 0.3420, that is calculated to be 0.455. Now in the question they have asked for the reduction in intensity of light, so that too in percentage. So percentage reduction in intensity will be the reduction in intensity from the initial value, that is I0 minus I, by the initial intensity, that is I0 into 100, since we want the answer in percentage. So on minimizing this or on solving this, we'll get 1 minus I by I0 into 100. So that is equal to 1 minus 0.455 into 100, because we calculated I by I0 equal to 0.455 here. So 1 minus 0.455 into 100 will be equal to 54.5%, which is the required answer for this question. Moving on to the next question, the fundamental vibrational frequency of H1 and I127 is 2309 centimeter inverse. The force constant for this molecule is dash nanometer inverse. We know that the equation connecting the wave number nu bar and force constant k is nu bar is equal to 1 by 2 pi c root k by mu. And mu is nothing but the reduced mass given by mu is equal to m1 m2 by m1 plus m2. Now let's calculate the mu for Hi. So that will be 1 into 127 by 1 plus 127, that is obtained to be 0.99. Converting this into kilogram, we have to do it, we have to multiply it by 1.66 into 10 raised to minus 27 to get it in kilogram, right? So now squaring on both sides, we'll get 4 pi square c square nu bar square is equal to k by mu, or k is equal to 4 pi square c square nu bar square mu. This is nu bar square mu. So we have all the values now. So substituting all the values here, we'll get force constant k is equal to 310.9 kilogram second raised to minus 2. So Newton is nothing but kilogram meter second raised to minus 2. And since we need the answer in Newton per meter is equal to kilogram second raised to minus 2. Now we have obtained the equation in kilogram second raised to minus 2, which is nothing but Newton meter raised to minus 1. So our answer will be 310.9 Newton meter raised to minus 1. We'll be discussing the remaining numerical answer type questions that came for GATE 2021 in the next video. Thanks for watching. And also don't forget to subscribe for more videos.